Cool. Hi, everyone. Welcome to week 4. Now we are on week 4, so that marks halfway throughout our Intro to CS. Very interestingly, um, around here is also where we will begin to move towards project-based approaches during our workshops rather than the current worksheets that you're seeing recently. You will see what I mean once we get to the worksheets. All right. So hopefully everyone had some fun last week with the workshop. Um, I think the challenge question, you had to implement a high-low game. For most of the submissions that I've read through, many of you have successfully implemented that game. Some of you have even added some very interesting parts to the game in your own flavor, either in terms of different prompting, different messages you're giving back to the user, etc. Those are all very cool. I really loved reading through every single one of them. All right, cool. Let's move on to week 4. So for this lesson, we will be going over X. Let's start, however, with a little bit of review. Now that we're halfway through, we've talked about a lot of different concepts in computer science that are very integral to the basics and fundamentals of computer science. I want to quickly cover them real quick, just to be sure that everyone is still on the same page here. If you have any questions throughout this part, please feel free to stop me and ask me at any time. If you're in Discord or on Twitch, just drop a message in there. I think Ray will let me know. Otherwise, if you're on Discord, Lucia should be around as well to answer your questions. Okay, immediately, very first part of our lecture during about 2 weeks ago, we went over variables. Simply said, variables are an abstract hold of value. In here, we can see example being A, B, and C being set to different values using the assignment operator, which in Python is equals. Next, we went over functions, which are ways that you can bundle together series of execution so that you can do these sets of execution again and again with potentially different inputs and different outputs. A nice way of ordering and organizing your code, as well as making it more readable and easier to read and write. And not only that, we also went over loops, which is a way of infinitely or potentially not infinitely doing something over and over again. Loops are pretty important in computer science, as there are many cases where we will perform many actions many times. In the example here, it's an infinite loop. While true, print hello world. So we will just print hello world over and over again without stopping until you or the computer decides to stop the program. We also went over conditions, which are very important in determining branching logic in computer science. For Python, the simplest example here is an if-else block. Oh, hold on, let me get my pointer. An if-else block is a very, very simple conditional operation that allows you to have branching logic depending on what you're checking. During this week that we talked about conditions, I've also introduced specific types, such as a Boolean type, which can be either true or false. Okay, before I move on to objects, does anybody have any questions regarding what we just covered? It was a fairly quick review, but hopefully these concepts in their basic understanding is fairly set in everybody's minds. And of course, feel free to stop me at any time. Just start jumping or something. All right. Now, for the new topic that we will be covering today, we will be talking about objects. Before we get into what are objects, we want to provide a little disclaimer. There's a lot to read on the board here, so I won't be making anyone read these. As a TLDR, there are a lot of different ways that you can structure any program that you're doing in computer science. Specifically for Python and programming languages such as C++ or Java, these programming languages are considered object-oriented programming languages. In object-oriented programming, it is a very specific way of modeling what data and what methods and how organization should be done within not only the code, but also the data itself. These are called programming paradigms. Programming paradigms are essentially different principles of programming that covers how you should structure something and why. We will be covering object-oriented programming because Python is our main language that we are using here to teach computer science. And object-oriented programming is also the most common thing that you'll see out there in the real world. It is very likely that you will see object-oriented programming in jobs or different open source interesting code that other people are writing. So as part of this, I want to make sure that everyone knows there are different ways of formatting and structuring your program out there, such as functional. However, we will be covering object-oriented programming. If you're interested in learning more different programming paradigms, I would heavily suggest everyone going and taking a look into functional, which is another very popular and very interesting way of handling things. All right, won't be going into too much depth. This is an intro course. Let's talk about objects. The most important thing for you to know about an object is that objects in object-oriented programming and Python in general represents a series of data and a series of functions to properly perform a set of instructions that describes what that object is. So let me give you an example. Well, here we have an example. We are using class. A class is the simplest object that you can make yourself inside of Python. When you declare a class, you're basically defining how this object looks like, what data it contains, and what it can do. For the example here, we have two numbers. We have an x and y that is initially set for us, and we also have a function that is defined within the object. This function describes what this object does and what it can do. In this case, we are adding the object's own variables together and returning it. There's a typo here that we made, but it's been fixed on the slides that will be shared out later tomorrow. So apologies for the typo, but here it should be print myExample.x. Couple of terminologies here. Variables that exist inside of classes are called member variables because they are a member of the object. Same thing with the functions defined within objects. Something that's very interesting to note here. Everything that is defined within the object can only be seen in the context of this object, which means if you try to access x and y outside of the context of the object, and you have not defined x and y, you will not see these variables. Same thing with this function. Another interesting keyword that you'll see here is the word self. In Python, self refers to the object. So when you say things such as self plus x, self point x plus self point y, what you're doing is you're accessing the member variables within this object. Now, what's happening in the last two lines down here is that we are defining an object. And you'll notice defining the object looks a lot like setting a variable. And you would be correct. We're making a variable called myExample here that holds the object. Creating the object looks a little bit like a function, doesn't it? With the parentheses at the end. And that is because we are calling a function. Every single object has a built-in function called a constructor. Constructors create the object. By default, within Python, the constructor is written for you. For languages such as C++ or Java, you may have to define these constructors yourself. Now, what is happening here when you call the constructor? When you call the constructor, Python is going to attempt to make an object. In this case, we are making example. By making example, we are now returning that object to be set to a variable or to be used immediately. In this case, we save this object. And we will attempt to print x from this object that we have saved. Can anyone here tell me this will print? Aurora.
20.
That is correct. And we will print 20 because when we have constructed the object, we have set 20 to x. Please note that it's only set to 20 because we have deemed it to be. In many cases, objects may have variables that are not set, and you may have to set it yourself. All right. I just talked a lot about the inner workings of object, different things that are not written down here, such as the constructor. Does everything make sense so far? The concept of what an object is within Python. Just as a recap, the most important thing that you need to know about an object is that object holds very specific data that is important to itself and very specific functions that are also important to itself.
Uh, Excuse me. Last class I
Yes,
was
question
been
from the
told
audience.
was there's a bug in that example where the printout is calling out the wrong variable here. So here the example is basically the class that's been created, but then when you add print, it basically says print my trans academy example when there is no such variable created, so it's going to cause it to crash.
That's correct. There's a typo here on the slides. We have fixed it on the actual slides, but it didn't make it onto the world. So when you get these slides later tomorrow, you will see it fixed within the slides itself. But yes, just a quick disclaimer. There is a slight typo here that we have made. Sorry about that. Instead of Trends Academy example, it's supposed to say my example, referring back to the variable that we have declared up top. Hope that makes sense to everyone. And yeah, thanks for pointing it out.
You're welcome.
All right, now let's take a look real quick at why objects are good, but if you don't know how to use them, then the point is a little bit moot. Why do you even use an object? And why should you care about these types of organization? Simply put, when we have complex logic that requires a certain specific thing interacting with certain specific other things, we can group how they perform certain methods into larger objects that make sense to us. Let's take a look at these two examples, and I'll give you some more examples. Take a look at the code below. X equals 4, x equals 10, and we do an add and subtract. By keeping things organized within an object, it makes a lot of sense for us to call these objects with their specific functionalities. So class example here is clearly doing addition, subtraction, and maybe it can do more mathematical operations. In this case, by keeping everything organized within an object, it is easier for you to create more complex code for you to understand later. As an example, if you were to make a game, you would have an enemy and a player. The way that we calculate, let's say, damage for the player and the way that we calculate damage for the enemy might be different because they could have different stats. So rather than putting the stats everywhere within the code nilly-willy, we can stuff them all into a class that makes sense for them. And by keeping all these things organized, it is also harder to introduce bugs in the future. Because now that functionalities and variables are contained within their own classes, you cannot refer to the wrong object accidentally. At least it's very difficult because you have to very specifically call the object beforehand. Does this make sense? This is a bit more nuanced in the way that we are doing programming in the past couple of weeks. Anybody have any questions? I want to make sure that I'm really making sense here before we move on because I know that objects can be a little bit daunting at first. But
Can I
once
speak real
you
quick?
settle down in your mind, yes, question here?
I'm up here.
Oh, hi.
So, it's actually my first one here today. Uh, I do, I do want to learn more about this. I was hoping I could access this sort of information somewhere. I mean, I know it's not the same as being here IRL, but at least that would help me.
Okay, question from the audience. You're new to the class, you want to access information like this somewhere else? Are you asking
Is it
for more
possible?
resources?
Sort of, because I mean, this is actually my first lesson on this. I wanted to attend the other few, but stuff to put it bluntly.
The
But
other
yeah,
few have been
I do want
recorded.
to know where I can get these sort of resources.
Okay, so student in the audience asked where they can get more resources since they missed the previous lectures. Yeah, no problem. Um, if you see the Discord channel, feel free to send a ping to either Lucia or I, and we can provide you some links to previous recordings, as well as previous slides, additional links to other additional resources that you can read in the internet about computer science and how to learn. Hope that helps. Yeah, drop us a link and we'll send you more resources
Thank
your
you.
way.
I
Yeah,
will
no
go.
problem.
I will go do that. Give me.
It should be in the intro to CS section.
Right.
All right. Any questions about classes? Okay, we'll move on real quick. Let's talk really quickly about some terminology. We told you what classes are, and we told you why. Now let's look at how. In Python, class definition is very simple. We simply use the keyword class. When you use the keyword class in front of any name, you are now defining a new class. Within that class, you can define member variables, which are held only within that class. Same thing with the member functions. Creating a new class instance looks like this. We are calling the constructor. By default, we will construct a new instance of the class. However, if you want additional custom logic for when you are creating the class, you can actually write your own constructor. Self refers to the class itself. I think this example here is fairly self-explanatory, and the keywords here try their best to describe what they're doing. But I do recommend trying this out a little bit yourselves on this week's worksheet to really drill that down in your head. All right. Now we are going to cover a very unique thing about object-oriented programming. I'm going to introduce you the concept of inheritance, also known as polymorphism. Inheritance is a concept within object-oriented programming where you can construct similar classes with a little bit different or new features as another class. Now, you might be asking why. Well, this is actually a very common way of reusing your code and reusing classes that are very similar to each other. Let's show you a couple of examples. All right, so here, let's look at this class on the right. For a simple base class, we will be calling the highest topological class that you are inheriting from the superclass. Superclasses are what you're inheriting from. In other languages, this is also called the parent class. Very simple class here. We have one function called headpat. Now, we are going to perform an inheritance. in cat. On the example on the left, we will be creating a new class called cat, and you can see that we take animal inside the parentheses here. This is to note that we are now inheriting everything that is inside of animal down into our cat class. The second function with the underscores in the front and the back, called init, is the constructor. This is what constructs the class every time you're trying to make a new instance of it. For this specific case, we are calling super. By calling the super function, what we're doing is we are actually constructing the superclass and setting that to be the child class. Now, something that's very interesting that you'll see that's happening here on the bottom one is that we are actually overriding the functionality of headpat. And because we are overriding this, even though we are taking inheritance from animal, we have two separate functionalities here that are very similar to each other. Now you might be asking, okay, well, if I'm just gonna overwrite the one and only function within the class, why am I even inheriting? Well, that's because there could be a lot of other items inside of the superclass. An example here would be number of times headpat, or additional functions such as walking forward. These things might be the same. So when we perform inheritance, we can take over all of those all at once from the superclass. Now the question here for the audience, if anyone even wants to raise their hand, let me know. These two different headpat functions, which class will perform which? Anybody have any ideas?
I do.
Yeah, go for it.
Basically, the superclass is like the main category, and essentially the child class is the subcategory, and you will have to call a certain variable from within the superclass in order for it to. In other words, the superclass can't work without the child class, and there could be like lots of them.
So there's one thing you got opposite, which is the child class cannot work without the superclass. Remember that superclasses are at the top. Everything comes from the superclass.
Okay.
Without the superclass of animal, cat would not exist.
Okay, yeah.
So here, in these two examples, calling the two different headpads will provide us different prints depending on which class you're using. Both of these classes are considered animal classes, but the head class, because it is inherited from animal, it has additional or different functionalities, but similar.
I got one here.
Question.
Could I then add on to that by, like, say, could I make another class in cat? Like, could I do, for example, a lion, which is under cat, and a cat, which is under animal? Could I apply? Could I have the? I might sound really dumb here, but could I still do the head pat to a to something under the cats as a subclass?
So the question from the audience is, can I perform another layer of inheritance below cat? And the answer is yes, of course. In fact, you can have as many layers of inheritance as you want. This is either a good thing or a really bad thing. And the reason that I say that is because you can go down in many layers of inheritance to have cat going into lion and have lion going into, I don't know, like saber tooth or something. And
Lion cub.
as you make more inheritance going down, you will inherit the functionality that is the next level layer up. So, what I mean by that is if you make lion inherit cat and you call head pat without changing it, you will actually call head pat from the cat class. So, next layer up, basically. Hope that answers your question.
Mm-hmm.
Another question here, Aurora. I also see you raising Fireball.
Uh, when we create a variable which stores one of the objects, when creating one for cat, we do not need to refer to animal in any way, right? Am I understanding this
It's
correct?
correct.
Okay.
So the question here is, when we're constructing the class and we're setting it to a variable, do we need to refer back to the superclass? And the answer here is no, we do not. And the reason is because the superclass is inferred within cat itself. So you will be creating a copy of cat. You do not have to worry about animal. Hope that makes sense.
Thank you.
Pearly.
Right. I kind of understood the code until now, until the in the child class it says define and underscore underscore init underscore underscore. What exactly does that one mean?
Yeah. So let's go back to this example real quick. When we construct our class, therefore, when we're setting our class to a variable, what happens here? You'll notice that we have parentheses afterwards. These parentheses actually call a very specific function called a constructor. The constructor will actually create the class and pass it back to the variable. In the example here for cat, when we do define underscore underscore init underscore underscore, this within Python is what the constructor looks like. Very importantly, the constructor here calls super. Super is referring back to the constructor of its parent class, which in this case is animal. So what we're doing in this case is we are creating an instance of animal, and then we're overriding some of its functionalities, such as head pat. Does that answer your question for what init is?
Yeah, kind of, but yeah.
Yeah, if you have a follow-up, feel free to ask that as well.
All right. I think I get it.
All right, Fireball.
Do you have to define a superclass as a superclass, or can you feed any class into any other class?
Good question. The question was, do you have to define superclass differently from other classes? The answer is no. The only thing that you have to do differently when defining classes is you have to define the child class differently. More specifically, which class it inherits from. In this case, cat specifically inherits from the superclass. Now, very interestingly, every single class that you define can potentially be a superclass. Class only becomes a superclass when there's a child class that refers to it. By default, they're all just classes. Hope that makes sense. Another question here from the audience. Arar, go.
Can a child class refer to multiple superclasses?
Oh, all right. So question was, can a child class refer to multiple superclasses? So I would have to say it depends on the language. It really does. Object-oriented programming is a design paradigm. In design paradigms, different functionalities can be different throughout different programming languages. I know some programming languages that could, some programming languages that could not. For Python, let me get back to you on that because I don't want to tell you a wrong information. I'll look it up and I'll ping you after class.
Thank you.
Question from Farpal.
From Twitch chat, can there only be one superclass, or can cat have multiple superclasses?
Yeah, I think same question as Aurora. Again, it depends on the language. I'll have to double check on Python, and I'll get back to you. And maybe Lucia can answer this in the chat if she's around. All right. Any other questions, either from Discord, Twitch chat, etc.? Well, let me do a quick recap. Okay, just as a super quick recap. This week, we covered classes and object-oriented programming is a design paradigm. Classes are important because they hold specific data and specific functionality that are meant to be grouped together. So, for example, animals and their behaviors. For animals, we could give it names, we could tell it how to run, etc. Another very important paradigm within classes is the concept of inheritance. Inheritance allows you to have different functionalities or the same functionalities with a little bit of changes. The reason that inheritance is important for classes is because when you have very complicated classes, you don't want to be rewriting everything again, especially if they're very similar. In this case, we're reusing some of what's inside of animal for cat. Question from Aurora.
When you import the superclass into the child class, do you have to use underscore underscore init underscore underscore, or would anything do so long as you call the super function?
Yeah, good question. So the question here is that do you have to call super within the constructor or can you call super somewhere else? Well, super has to be called during the construction. So If you do not call super immediately within init, then maybe your constructor can refer to another function within the class that eventually calls super. But without calling super, your construction of this child class would not be complete. Does that make
So
sense?
underscore init to underscore is the constructor for cat. Uh, and when you call super within the constructor, you import everything from the super.
Yes.
Okay.
So just a recap of what Arar just said. Underscore init underscore is the way that Python refers to the constructor. The constructor is the piece of function that runs when your object is created. That's why it's called constructor, because it's constructing the class. Super inherits everything from your parent class. Without calling super, you won't be inheriting anything. Here, in this case, we're calling super immediately inside of the constructor. However, if you want to do something specifically before calling super, then you can as well. Hope that makes sense. All right. Let me look around a bit. I will have to say, classes is probably the one thing that I struggled the most with when I was first learning computer science. Classes are not very easy concept to understand because probably until now, there hasn't been a need to use classes. It's hard to see why classes would be important. And the reason is because the programs have just not been complex enough. Once the programs get more complex, which it will as we move out throughout the weeks, we will be building on some of the stuff that you may have been written in the previous weeks. The reason why classes is such an important concept is because you will find later on that organization is almost just as important as making the right program. Without organization, it's very easy to introduce bugs. It's also very difficult to program new things. And you'll find that you'll be copy and pasting a lot of code everywhere, which will make it work. But in the long run, things just gets more and more confusing. And when something goes wrong, it becomes a bit of a nightmare to debug. In terms of programming paradigms, object-oriented programming is something that you'll see very often in a lot of different programming languages. If you're ever familiar with C++ or Java, you will definitely see this structure. Right. Any questions from Twitch chat? Any questions from Discord? All right. Okay, I'm just gonna make a note here. During this week's workshop, we will begin to work on a little bit larger objects and a little bit larger projects that you will be working more slowly and building upon as we go throughout the weeks. The goal here is for everyone to have one big complete project by the end that you can show off. So, starting from this week, one thing that will be different within our worksheets is that we will begin to utilize code that we may have potentially been writing in the past. So just keep that in mind. All right. And that's everything from me. I will give about 30 seconds here if anybody has thought about something. Otherwise,
Hmm.
as always, you know where to reach Lucia and I. Oh, yes. Over
Are
here.
classes the only like type of object in Python?
Yeah. So the question here is, are classes the only type of objects in Python? So when we talk about objects in Python, objects cover a large variety of different things inside of Python. Many different objects that you may have seen in the past. Lists. We introduced the concept of lists sometime back in, I think, like week 1, week 2. Lists are a special type of object as well. And they have their own functionalities and they have their own member functions as well. Objects cover a wide variety of things within Python that have their own individual data and their own individual functionalities. So lists cover all of that. In next week's lecture, we will be going over some very specific data structures that exist in Python, where I'll introduce to you more objects. But for now, classes are one of the simpler ones where you can construct your own object with your own data values and your own functions for methods and functionalities. In other languages, you will sometimes see struct. Structs are a collection of different types of values. That is also considered an object. In Python, almost everything can be considered an object if you boil it down far enough. So sorry for taking so long to answer this question, but the short answer is no. The long answer is classes are a very easy object for you to define as the programmer. Hope that makes sense. Don't see anybody's hand raised. I don't have everyone's avatar showing, so if you're raising your hand and I'm not calling on you, please jump up and down so I can see you. Yes, Pearly.
Yeah. Do you think that how can I put it this way? I know that AI is going to change everything, but I imagine that it's going to be more like for larger projects, right? That's essentially what AI is going to do in terms of like creating code, right?
Sorry, you mentioned AI for creating code. What is your question?
Is that only going to be used for larger projects where, you might need to, you know, create complex. Basically, is it going to be used for large projects all the time?
Okay, so the question here, specifically covering AI, is AI only going to be used for large and complex projects? The answer is no. In fact, many of our students have been utilizing AI within our worksheets to help them explain something or maybe to help them check how certain code works. Simply put, AI, like any other tool, is basically how you use it. Obviously, in larger and more complex projects, AI is arguably more useful. However, AI has to be correct. And in order for you to be sure that they're correct, you as the programmer has to understand the code first. At the end of the day, AI is just another tool. It really depends on how you use it. Sorry for the roundabout answer. There's no really
Right.
good way to tell you when you should use AI. It
No,
depends on you and how much you want to learn at the
no,
end.
no, no. I just wanted to get a picture on how AI is going to change programming as we know it.
Uh, okay. So, question is, how will AI change programming as we know it? Wow. That is a question that almost every programmer is asking, and no one has an answer to because no one knows. We all know that AI is going to be more integrated into the developer experience. As you code, many of us have already interacted with AI or will interact with AI in the future. In terms of how it's going to change the experience, I cannot give you a definitive answer. But I can tell you that AI will very likely be used more in the future as it gets better. Hope that makes
All
sense.
right, thank you.
Hey, going once, going twice. Anything from Discord, Twitch? All right. Thank you, everyone. This has been week 4. We're halfway there. See you in the workshop on Friday in about 2 days. And I will be looking over everyone's worksheets that I might have missed. Thank you for coming, everyone. I'll see you later this week, and we'll catch you next week where we will be covering some additional objects and data structures within Python.